Assalamualaikum warahmatullahi wabarakatuh. My name is Rinolida. I am from UIN Araniri University Banda Aceh, Faculty of Science and Technology. So today I will review the journal entitled Towards Understanding the Value of False Positive in Static Code Analysis. This journal written by Carlo Di Mastro Giovanni from Polytechnic University of Turin, Italy, and Nuno Laranjeiro from Department of Informatic Engineering, University of Coimbra, Portugal. Abstract: Static code analysis is a well-known technique used to detect potential software security issues nowadays, given the large variety of vulnerabilities and the increasing complexity of web applications. It is difficult for static code analyzers to identify vulnerabilities in a precise manner. The main problem is with the typical high number of false positives reported by these tools, which refer to vulnerabilities that, in practice, do not exist. The common view is that the information regarding false positive is useless. In this paper, we give an initial step towards investigating the hypothesis that false positive may be, in fact, a link to potential security problems. We analyzed 3 open-source web applications, used a well-known static analyzer, then identified false positive and linked these to potential security problems. Preliminary results suggest that in many uses, the presence of a false positive indicates a fragility of the application, which often, in different degree, to turn into a real vulnerability. Introduction: Web applications are becoming more and more popular day by day. In order to deliver advanced functionality, they are also becoming more complex, which favors the emergence of new, hard-to-find, and potentially problematic vulnerabilities. The current time to market pressures combined with the typical lack of adequate preparation regarding security of application leads developers to overlook security in favor of the deployment of functionalities. This results in web applications that are exposed to a high number of users on the internet, and that may carry serious security problems. This analysis is performed using the source code or object code depending on the tool used, and tries to detect vulnerabilities by searching for code paths that are prone to be insecure. Approach: In this paper, the target is set on web application, and therefore any application of this type will do, as long as we have access to the source code. In many cases, having bytecode access will serve the static analyzer, but in the end we need to confirm all the vulnerabilities reported, and most of the time we can only do that by using the source code. The second step is to select one or more static analyzers that can be used to test the application, select and produce security report. For instance, in the context of the experiment, in this paper we are targeting SQL injection vulnerabilities. So, if using several static code analyzers, they should be able to analyze this type of vulnerability. Experimental evaluation. Experiment configuration. The static code analyzer used in our experiment is Findbugs version 3.0.1 developed by the University of Maryland. It analyzes Java programs operating on their bytecode. Potential vulnerabilities are ranked from 1 to 20 and grouped into 4 categories from scariest to of concern, providing a hint to the user about their possible severity. Findbugs can be run from the command line and Maven or in a standalone GUI application. Findbugs is based on code paths detectors, and it is possible to add new ones using plugins in order to have more complete set of rules regarding security. We use the plugin Find Security Bugs version 1.4.4. Findbugs allow the use of filter files, which are XML documents used to include or exclude bugs report for particular type of vulnerabilities, class, and method. D. Result and discussion. Table 1 presents an overview of the result obtained during the experiment. In particular, the table shows the web application test, the number of SQL injection vulnerabilities reported by Findbugs, the number of false positive found, and also the different types of SQL injection vulnerabilities identified by the researcher. In Table 2, we summarize our findings with respect to the distance to becoming a vulnerability, low, medium, high, for each of the 5 cases. And next, conclusion. In this paper, we present preliminary work to investigate the hypothesis that false positive generated by static code analyzer are not useless, but might bring in useful information regarding the security of web application. Research suggests that the presence of a false positive is often due to a bad programming practice, and small details might prevent it from becoming a real vulnerability. In the dynamic web environment, this possibility can usually turn into a problematic reality. The different cases of false positive found during the experiment show that sometimes there is no practical way of turning a false positive to a real vulnerability. Thanks for watching. Assalamualaikum warahmatullahi wabarakatuh.